Okay, so last section we're going to look at is 8-4. And it's, again, on a little bit more you can do with complex numbers in trig form. But it has to do with raising to a power and taking a root. So we already have a way to raise something to a power. Okay? So let's just look at an example of raising something to a power the way we already know how to do it. So let's look at make something. Okay, I'm not going to pick a very big power. I'm only going to pick 2. So remember what that means. 3 plus 2i times 3 plus 2i. And you have to use the distributive property to do all that up. What's 3 times 3? Gives me 9. And what's 3 times 2i? 6i. And what's 3 times 2i again? Another 6i. So how many i's is that? It's 12i. And then we have a positive 2i times a positive 2i. Well, positive times positive is positive. What's 2i times 2i? 4i squared. Okay, now, I squared is really what number? I squared is -1. Okay? So what's 4 times -1? That's really a -4. And we can combine like terms. What's 9 minus 4? 5. There you go. So that's the answer when you raise 3 plus 2i to the second power. So now, what if we had 3 plus 2i to the fifth power? Well, if you wanted to do that the way I just showed you, you would have to write 3 plus 2i 5 times, and you'd have to FOIL the first 2. You'd get this answer, and then you'd have to keep doing more FOIL, okay? Because you'd have it 5 times. It'd still be doable. I mean, to write it 5 times and do it. A lot of arithmetic, so you might make a mistake. But I would say you could easily do that, no question, under 5 minutes. Okay? It wouldn't take like hours and hours. But if I gave you something like 3 plus 2i to the 543rd power, well, now we've gone beyond what you're going to be able to do on paper. Okay, you're not going to be able to write 3 plus 2i 543 times. And that's going to take you an hour alone, probably. And then you got to FOIL all of it together. And there's little shortcuts you could do, but even with shortcuts, it's not going to be a problem that's doable. So when you're trying to raise a complex number to a power, there's a much better way to do it. And that's if you write this in trig form. It becomes a very easy problem to do. And that's what we're going to look at. So we're not going to go through the proof. I could, but I'm not going to. But here's a complex number. It has a radius and it has an angle. And I'm calling this complex number z. Well, I want to take this entire thing, which I'm calling z, and raise it to the second power. If we were doing this in standard form, this is where you do all the FOILing. You get the I squareds and all that stuff. If you want to do this in trig form, let me show you what the answer would be. It would be r squared cosine 2 theta I sine 2 theta. What I just did in trig form, right there, took the place of all of this. I basically did it in one step, raising this to the second power. But it had to be in trig form. So if it wasn't in trig form, like let's say I wanted you to take this and raise it to the fifth power, you can use the shortcut that I'm going to explain more in a minute. But you got to change this to trig form first, like we learned on the homework, then you can use the shortcut. And it's definitely worth it to change it to trig form. It definitely saves time. Now, based on the pattern for z squared, anyone think they know what z cubed would be?
R cubed cosine 3 theta
Cosine 3 theta.
plus I sine 3 theta.
Yeah. Yep, that would be r cubed. And z to the fourth would be r to the fourth and a fourth theta. If it was raising to the sixth power, it would be an r to the sixth and a sixth theta. This pattern is called de Moivre's theorem. Okay, that's the name of this pattern, de Moivre's theorem. So if you have something in trig form and you're raising it to an integer power, you can't raise it to like the 1.3 power. We don't look at that anyway. But this only works if this number is not a decimal. The two things you have to do is raise the radius to the power and multiply the angle by the power. Those are the two things. Okay, so raise the radius to the power, multiply the angle by the power. You're going to have that for? Okay, so just to show you that it works, let's change, we already have the answer. It's 5 plus 12i. Let's change that to trig form. Let's try de Moivre's theorem and see if we get the same answer. Okay. Again, to the second power, I don't think de Moivre's theorem saves you any time. It's when this number starts to get huge. Then de Moivre's theorem makes it so much easier. Okay, but let's just try it. Okay, so if we were going to write that in trig form, write 3 up 2. How long is the bottom side of the triangle? 3. And the height? 2. Okay, what's 3 squared? 9. And 2 squared? 4. And 9 plus 4? 13. So your radius with the Pythagorean theorem is square root of 13. Okay, what quadrant is that point in? 1. What's the formula to find your angle in quadrant 1?
Arctan of y over x.
Arctan of y over x. What's y?
2.
Y is 2. And what's x?
3.
3. Now it's going to come out to a decimal, but let's do it to 3 decimal places. So hopefully when we do this, we get something maybe like 4.9999. It'll be close. So we'll round it to 3 decimal places. Okay, 33. It's actually pretty close to that. 33.69, and that is pretty accurate because the next 2 numbers are zeros. So 33.69. Okay. So now let's write it in trig form. R cosine theta plus I sine theta. Okay, so I've got it in trig form. Now, what power do I want to raise it to? Second. Let's raise that to the second power. So the first thing I need is my radius. What am I going to put for my radius?
13.
Yeah, because you're going to take, I'll just write it, square root of 13. You raise your radius to the power. Now my angle, how am I going to figure out what my new angle is going to be? It's not 33.69. Multiply the angle by the power. So 67.3 So 67.38. And now what happens when you square the square root of 13? Yeah, we just get a 13. Now, that should be the answer. It doesn't look like this one, because that's standard form. That's trig form. Well, take the 13, multiply it out, and that should give us exactly the same thing. Let's see. So 13 times the cosine of 67.38. 5. Basically 5. And what do you think I'm going to get when I do 13 times the sine of 67.38? I'm going to get 12. Yeah, with an I. Okay, let's see. So 13 times the sine of 67.38, basically 12. So what I'm trying to show you is if you take and do it using the theorem I just showed you, you get exactly the same answer as if you did it the old way. And again, I would not do a power of 2 with the Moivre's theorem. It's easier to do it the old way. The higher powers, it's easier to use the new one. Yep.
When we're going to the third decimal, do we round to the third decimal or should we just take the third decimal?
Well, you round properly, so you got to look at the fourth decimal.
Okay.
And if it's 5 or higher, you got to round the third one up. All right, let's try this one. 1 plus root 3i to the third. Now this could go either way. Do I just FOIL it the way it is and write 1 plus root 3i, 1 plus root 3i, 1 plus root 3i, and then do all that out? Or do I change to trig form and do it that way? In terms of time, probably pretty close to the same if you're really fast at FOILing. But they said to use de Moivre's theorem, so that's what we'll do. Okay, what quadrant is that in? First quadrant, positive 1, positive root 3. Right about there. What's the bottom side? 1. What's the height? Root 3. Okay, so now using the Pythagorean theorem, what's 1 squared? 1. What's the square root of 3 squared? 3. Add them up and take the square root. So what's my radius? 2. And this is a 2. Okay, so we got that. What's the other thing we need? We need the angle. And in quadrant 1, the formula for the angle is
Inverse tangent of y over x.
inverse tangent y over x. So it's really just the inverse tangent of root 3. And hopefully we kind of remember when you're working with root 3 and tangent, the answer comes out nice. Inverse tangent root 3, 60 degrees. Okay, so now let's write our answer and then raise it to the third power. So r cosine 60, I sine 60. Just to be clear, we haven't raised anything to the third power yet. That's just changing this to trig form. Now we're going to raise it to the third power. Right, follow the 2 rules. What do we do with the radius in this problem? Raise it to the third power. What's 2 to the third power? 8. What do we do with our angle? No, we don't raise 60 to the third power. We times it by 3. And what's 60 times 3? 180. That is the final answer in what form?
Trig form.
Trig form. So if the problem doesn't say how to leave the final answer, then that's fine. That's the way you can leave it. If the problem said to write the final answer in standard form, how do you get that into standard form? Distribute the 8 to the cosine. So 8 cosine 180, that's -8, plus distribute the 8 to the sine. 8 sine 180, 0. Eight times the sine of 180 is 0. What's I times 0? So in standard form, what's your final answer? -8. Yep. Any question? Okay, so what did we do in this problem? We took this, and what did we do to it? Well, what did they ask us to do to it?
more theorem into trig form. We raised it
Well, that wasn't the directions. It didn't say change it to trig form. It just said to take that and do what?
raise to the power of 3.
Just raise it to the third power. We used Moivre's theorem, which involved what you said, so we had to do that. But the directions were to raise that to the third power. Now, that's the answer that we got. How would you go back? How would you undo raising something to the third power? You take the cube root. So if you took the cube root, now I'm going to show you how to do it. If you took the cube root of that number, that's the answer you would get. More specifically, it's one of 3 answers you would get. Whenever you take a root, there's always as many answers as the root you're taking. A cube root has 3. A fourth root has 4. Fifth root? 5. So you might think, well, wait, if you take the cube root of -8, I know it's -2. -2 times -2 times -2 is -8. Yes, that's one of them. So is this. That's another one. So that's what we're going to look at now. How do you take -8 and change it back to that? How do you do a root? Okay, so that's a power. So we already answered this question. Looking at example 1, how do you reverse cubing something? We said it's cube root. Okay, so we already said this. So if you take the cube root of -8, one of the answers is this. There are 2 other ones. The nice thing is if you visualize all the answers by graphing them, if there are 3 answers, the 3 answers would look exactly like this when you graph them. What does that look like? How about more specific? Equilateral triangle, yes. Okay. The 3 answers, if you graph them, they look like the corners or the vertices of an equilateral triangle. If you had a 4th root, it would have 4 answers. If you graphed all 4 answers, the way I taught you how to graph yesterday, they would look like this. They would be the corners of a square. If you had 5 answers, they end up being the corners of like a pentagon. So once you get one answer, if you're visual, you can kind of get, if I had let's say I was doing 4th roots and I had an answer right there, well, I can automatically figure out all my other answers because I know that's right 2 and up 2, and I just got to figure out the ones that would make it a square, and they're centered all around the origin. So I'd have to have one like over here, I'd have to have one down here, and I'd have to have one over there. So it's like 2 plus 2i, 2 minus 2i, and so on. Okay. We don't have to worry too much about the visual, but some people that are visual, it might help you to think that way. Okay, so how do we how do we do this? Alright, so this is the one that we're going to do. We're going to find the fourth roots of 1. Sometimes when they ask you to find the roots of 1, they consider 1 like a special name. They say find the roots of unity. If you don't like the word unity, you can just cross it out and put 1.
Why would they do that?
I don't know, because they don't do that for any other number. If it's any other problem, they just say like find the fourth roots of 12, or find the fourth roots of 18, something like that. But for 1, sometimes they use a special word. Yeah, but just put 1. So when you are solving a problem to find roots, this is the equation you need to set up. It always has z, and in this box is the number that represents the root. So in this case, we're doing a fourth root, so you put a 4 in that box. So it's the number, I guess you could call it the number of the root. If it was a cube root, you'd be putting a 3 in that box. If it was a square root, you put a 2. And then on this side, that's what they give you in the problem. So that's given. It's what you're taking the root of. You're taking the square root of 7, 12. What's the number they want you to use? Okay, so you have to get those two things from the problem. Okay, so let's start with z to the fourth equals 1. Okay, the first step is that is not trig form. If it was trig form, I would be seeing sines and cosines. So I think what I'm going to do is I'm going to put the steps under the problem as I do it, rather than off to the side. Okay, so the first step. Z is what you're solving for. Okay, that's the answer to this problem. How would you normally get z by itself in that equation and get rid of that exponent of 4?
Fourth root.
Yeah, you take the fourth root of both sides. And that's exactly what we're trying to figure out. The problem is, if you just take the fourth root of both sides like that, you don't get the imaginary answers. Okay? So I have to show you how to get the imaginary answers. But that's essentially what we're doing. We're going to take the fourth root of 1, and I'm going to show you how to get all the answers. So, on the left side, first thing you have to do is change that to trig form. We don't know anything about it. That's what we're solving for. In trig form, what are the two things you always write down?
Sine and cosine.
Well, you got the sine and the cosine, and like what's in the front?
The radius.
The radius, and then what's inside? The angle. I don't know the radius or the angle for z, so I just have to leave them as variables. So change z to exactly this. R cosine theta plus I sine theta. Yeah, change that's a t. The other thing we have to do is change the number on the other side to trig form. This is not going to have any variables. I can figure out what that is in trig form because they gave me a number. It's like a problem from the homework last night. So change number on right side to trig form. Okay, so let's do those two steps. Change z to r cosine theta plus I sine theta. So r cosine theta I sine theta, and it's still raised to what power? Yeah, the 4 stays right where it is. Does this look kind of like something we just did?
Yes.
Yeah. We're going to do on this exactly what I just showed you how to do with the radius and the angle. Now, the right side, that's what we did in the homework last night. Let's graph 1. If it looks confusing because there is no imaginary, just think of it as plus 0i. How do you graph 1 plus 0i?
Up one from the origin.
Not up
Right
one.
one.
Right one. Now I need to know the radius and the angle and write that in trig form. What's the radius in that picture? It would just be 1. You don't use Pythagorean theorem when you're on an axis. You just count how many up, over, or left or right. Okay, so the radius is 1. And what's the angle when you just go to the right?
0.
That's 0 degrees. Yep. So you don't even need inverse tangent. You are going to do inverse tangent in the next one. Okay, the radius and the angle is going to be more like we did with Pythagorean theorem. Okay, but that's easy. Okay, any question on that? Now, on the left, use de Moivre's theorem. Is that M-O-I-V-R-E? M-O-I-V-R-E, yeah. Okay, so on the left side, use de Moivre's theorem. Okay, so right side, I'm just going to copy that over. Okay, now, how do you do de Moivre's theorem on the left? What's my radius going to be?
R to the 4th.
Yep, it's going to be r to the 4th. And what's my angle going to be?
4 theta.
4 theta. Okay. Now, what's one thing that we don't know on the left? We don't know the r. Okay, we don't know the radius. What is the radius on the right? 1. What's something else that we don't know on the left?
Theta.
We don't know the theta. We don't know that. That's my angle. What's my angle on the right?
0.
0. So now, set the radius on the left equal to the radius on the right. So radius on the left equal to radius on right. Set angle on the left equal to what do you think I want to put on the other side?
Angle on the
It's going to be leave a little bit of space there. Angle on the right. But when we solve a trig equation, you have to remember that we can have many answers, right? When you're doing a cube root, I told you it would have 3 answers. We're doing a 4th root. So how many answers is this going to have?
4.
It's going to have 4 answers. How are we going to get the 4 answers? It's going to come from something I write down right here. So you set the angle on the left equal to no, it's going to be 360 n. plus the angle on the right. That's the part some people might forget. But as long as you write these steps down, you can just follow them when you're doing the problem. Okay, so let's do that. So set the radius on the left equal to the radius on the right. Okay. Set the angle on the left equal to 360n plus, now what is the angle on the right? All right, so in this case it's 0, it doesn't really make a difference. But I'm going to put it there just so we get used to if it's not 0, you definitely need to put it. And I'm just going to add one thing in here is solve. Okay. How would you get rid of this exponent of 4?
Fourth root.
Take the 4th root of each side. And now we can, this is just the radius. When you're finding the radius, that's always a positive number because it's a distance. So if you're not sure what the 4th root of 1 is, you can plug it in on your calculator. Press 4, math, and then option 5 is how you take a root. Now I can type in anything I want to get the 4th root of. So you press 4, math, option 5. And I'm taking the 4th root of 1, which is just 1. We don't have to worry about anything else because it's not negative. It can't be imaginary. It's a distance. So that is going to be my radius. And it's going to be my radius on all 4 answers. So we can start getting all our answers ready. So I'm getting ready to write all 4. Oh, leave space there. We got all our answers ready. We just have to fill in the angle. Okay, so let's go back up to our angle. To get my angle, I need theta by itself. How would you get theta by itself in this equation?
Divide both sides by 4.
Yep. So divide by 4. I know I don't really need to divide 0 by 4 because it's not going to affect anything. But that might not be a 0 in the next problem. So theta equals, what's 360 divided by 4? 90. Okay, I'm not going to write plus 0. I don't need the plus 0. Okay, so that's your formula for theta. But what's n?
4.
Well, we have to get 4 answers. But we're going to start by letting n equal 0, then 1, then 2, then 3. That's how you get your 4 answers. So n, there has to be 4 numbers written down here, and they have to start at 0. If we were doing a 5th root, we would do 0, 1, 2, 3, 4. That's how you get 5 answers. If you were doing a cube root, you would do 0, 1, 2. That's how you get 3 answers. Okay, so this number is always 1 less than the root you're looking for because you start with 0. Okay, now fill them in. What's 90 times 0? 0. What's 90 times 1? 90. All right, what's 90 times 2? 180. And what's 90 times 3? 270. 270. And those are how you write your 4 answers. On the test, either 3 or 4 answers is the most you'll see. Because if you start doing like 8, 9, 10 answers, then it's a lot more to write. So this would be the most you would see on the test, 4 answers. Right? It's not a hard process. It's just kind of trying to remember what to do in the process. It's nothing more complicated than adding, subtracting, multiplying, and dividing. It's just remembering the steps. Okay, so we're going to try it now. All right, this time let's do, instead of a 4-3, let's do a cube root. Okay. I don't really want to do that now. Let's do the cube roots of, I think I have one. Let's do this one. Cube roots of 1 plus I. Cube roots. So before we even start, how many answers are we thinking? 3. And remember, your equation you're solving looks something like this. What always goes in this box? Z. That never changes. What goes in this box? 3. And what goes in this box? 1 plus I. Okay. Now solve that equation, and that's our answers. Okay. So the first step is to change this to something. What does the Z change to?
R cubed.
Let's do it in 2 steps just to make sure everyone follows that. Can you tell me what you change it to first, and then we'll do that after.
R times cosine theta plus I sin theta.
Plus I sine theta. And that's raised to what power?
Third.
Third. And then we'll do what you said in the next step.
R cubed
Okay, we can, yeah.
times cosine 3 theta plus I sin 3 theta.
Yes. I do that in the same step. If you want to, you can do that all in one step. All right, now the right side. We need to change that to trig form. Well, is it already trig form? 1 plus I? No, that's standard form. That's not going to work. It would be in trig form if it had sines and cosines. All right, where is 1 plus I? 1 to the right, 1 up. What are the 2 things that you need to write that in standard form? Radius and angle. Okay, let's make our triangle. How long is the bottom side?
1.
The height?
1.
1. And what's the hypotenuse?
Root 2.
Square root of 2. Now, I know we've gone over and up the same amount, but let's pretend we don't know what the angle is. What's the formula for the angle in quadrant 1?
Arctangent E
Inverse tangent of y over x. Okay, what's y? 1. What's x? 1. So it's the inverse tangent of 1 divided by 1, which is 45 degrees. Any question on the radius or the angle? Okay, so now let's write down the right-hand side. R cosine 45, I sine 45. Okay. Now the next step is to set up 2 equations. What's the radius on the left?
R cubed.
R cubed. And what's the radius on the right?
Square root of 2.
Okay, we'll come back to that. What's the radius on the left? Oh, I'm sorry, what's the angle on the left?
3 theta.
3 theta. And now here's the part you can't forget this part. What do we set that equal to on the right?
360 n
360n
plus 45.
plus 45. It's not a 0 this time, so it's going to be important. Okay, so let's finish this one off. How do you get theta by itself? 3, 3, 3. That's gone. What's 360 divided by 3? 120. And 45 divided by 3? 15. Bless you. Now we're doing a cube root. How many answers are we going to get? 3. We're going to get 3. So what are the 3 values we let n equal? 0, 1, 2. That's how you get the 3 answers. That's easy. We'll do that in a second. Okay, let's look at this one. R cubed equals root 2. What's another way to write square root of 2 with an exponent instead of this root symbol? 2 to the half, yeah. I think that's going to be easier to write it this way because of what we have to do in the next step. If you want to get rid of this 3, what power could you raise each side to do that? Yeah, you could raise each side to the 1/3 power. Because when you have a power to a power, what do you do with the 2 numbers? What do you do with a power to a power? Multiply. What's 3 times 1/3? 1. That's how you get R by itself. What's 2 to the 1/2 to the 1/3? 2 to the 1/6. There's your radius. If you were thinking at the original step, just take the cube root of both sides. Well, it's not wrong, but then you have this. It's kind of a messy way to leave an answer. The cube root of the square root of 2. Well, the cube root of the square root is just to the 1/6. What's that?
Would you take that on a test? There's a question.
A root in a root? No.
Yeah.
Just, do it that way. Yeah. Yeah. It's like leaving a fraction like 2/4. It's not reduced. Okay, so any question how we got the radius?
Would you prefer it in that form, or would you prefer 2 to the 6th root?
You could say the 6th root of 2, or you could leave it just like I have there. Yeah. For most people, I think they're just going to want to leave it like that. All right, let's write our answers. 2 to the 1/6, 2 to the 1/6, 2 to the 1/6. Now it just becomes a lot of just writing it all out. Cosine, cosine, cosine. Now you just have to fill in our angles. All right, so first number we need to fill in is 0. What's 120 times 0?
0.
Plus 15. 15. What's 120 times 1? 120 plus 15. Okay, 135. And 120 times 2? 240 plus 15. 255. Yep. That's it. Those are the cube roots of 1 plus I. So the one on the test is going to be very, very similar to this. With cube roots. There aren't a lot. I'd say there's maybe only 1 or 2 questions, maybe just 1 on this, and then there's maybe 1 or 2 questions on Dumois' theorem as well. So law of sines and law of cosines, those are the biggest part of the test. Okay, let me put up the test topics.
It's going to be okay.
Okay, so on 26 to 28, In the book, they say to do a graph. We're not doing the graph. You can still solve the other part, but you don't have to graph your answer. Okay, so we'll take a look at that first thing tomorrow, and then the test will be on 8.1 part 2 through 8.4.
See, like, let's pop